everyone. Thanks, Avner, for the introduction. So I'm Kfir. I'm the chief scientist at Basis Technology, and my plan for this session is to cover some topics related to how we use NLP to diagnose mental health disorders. Um, so it's going to be a very quick talk, but I'll give you some reference for more information. Um, so in the last several years, people have been exploring different ideas for using computational tools to process human language in order to detect some mental health disorders ahead of time, as well as building tools for providing assistance and treatment when needed. But in this session, I'm going to focus on the diagnosis part. Um, a mental health disorder as a background is an illness, right? Like every other illness that affects the way a person thinks, behaves, feels, and it is considered as a major disease. And there are many types of mental health disorders. I'm pretty sure that you're familiar with those names here on the screen: depression, schizophrenia, bipolar disorder, PTSD, and so on. The language that we speak, right, that we use, it reflects how we feel, how we think, and it is often analyzed by clinicians and mental health professionals to diagnose disorders, mental health disorders ahead of time, during interviews, and also for providing treatment. And obviously, NLP, natural language processing, is the technology that we use to process written spoken language automatically. And therefore, clinicians and data scientists together are collaborating and doing, these types of analysis that I will show now for many years. And they're looking at different levels of the language using some computational tools. And probably one of the most popular analysis in this field is done on the word level. It's a simple analysis. You can think about just simply counting words, how many times a specific word of a specific category appear in the text, which would be something, the text could be something that you write on social media if you want, or it could be something that you say and then record it, and then someone try to transcribe and then process the text. And so, for example, counting how many positive words you're saying in a piece of text or in a transcription, it could be interesting for detecting, some symptoms of depression, for example. The counting also can be done on the token level. Basically could be like, the surface form, the basic words, or the lemma, which is more like the base form of the words without all this inflection, clitics, or affixations, suffixes, prefixes. Very relevant if you are working on a morphologically rich language like Hebrew or Arabic. LIWC, if you're familiar with this, it's an interesting, very simple tool, linguistic inquiry and word count analysis tool. It's a psychometric analysis tool, and it organizes words into categories and subcategories that are relevant for some psychological conditions. So it has in its dictionary about 23,000 words. 2,300 words, organized in about 80 different categories. And you can see some of those here. It's just for example, the biological processes such as body-related words, social words, like, family-related words, there are affect words, functional words, like personal pronouns, and so on. It's all in English. There is a nice translation that was recently released by Natalie Shapiro and al. For Hebrew. And then if you use Look or LIWC, the results that you're seeing look something like that. I mean, you get like a usage rate broken down into the Look categories. And people use these representations for finding correlations between those, signatures of word usage and some mental health disorders. And that's a pretty straightforward analysis in this field, and it actually works pretty good. However, there are other characteristics, language characteristics that people are using to diagnose mental health disorder. For example, the part of speech of the words, like counting how many nouns are in the text or how many verbs, that may help assessing the complexity of the language that you use, suggesting problems related to poverty of speech. That's a major symptom of schizophrenia, for example. The syntax or the structure of the sentence might also be relevant for such an analysis. As for some disorders, it seems like the ability of forming a grammatically correct sentence is deteriorating. Different levels can be done on the semantic level, like calculating the similarity between words or phrases as a tool for assessing the cohesiveness of the text, and finally emotions and sentiments, also very important for depression related disorders like bipolar disorders as well. There are many works, many studies that people are doing on depression, for example. Here you can see in these examples for some of them. But the bottom line is that most of them connect depression with high rates of negative emotional words, and also high rates of self-reference words, or if you want, like first-person pronouns, like speaking about myself. Keep in mind that those specific works and some other works, most of the works, are doing their research on texts that are taken from social media platforms. Here you can see Reddit and Twitter. It's just because it's easy, it's relatively easy to get access to this type of data. If you want to get access to this data, you can simply search the platform for relevant key phrases, such as "I was diagnosed with depression," trying to find people actually reporting on such an event. And then you can look at the data that they're generating and process that for your own purpose of your research. And then for control group, that is people don't suffer from that specific disorder. You can simply select randomly users from the platform, but obviously that's not ideal because there is no guarantee that these people don't suffer from depression in real life. So there is a caveat in using that data from social media. So let's focus a little bit on schizophrenia, which is a mental health disorder affecting a bit less than 1% of the adult population. And some of the major symptoms of schizophrenia involve speech disturbances. So it's a lot about language. And those disturbances, they reflect underlying disorders in the way of thinking rather than just a pure language impairment. So it's not technical, it's about thinking. And the clinical community call these disorders thought disorders. I'll explain a little bit about that. How we try to detect them with computational tools. So schizophrenia is also being studied. It's an active research area, and these are a few examples of works that have been published. Anecdotally, the first work here, they found connection of schizophrenia with a high rate of absolutist words. Absolutist words are words, that like nothing or completely or always, kind of all or nothing kind of thinking. So it's an interesting work to follow. And as I said, thought disorder is one of the major symptoms of schizophrenia, but it also relates to other mental or developmental disorders, like the autism spectrum. So it's not just about schizophrenia, but we focus a lot on that. And the clinical community, they distinguish between different types of thought disorders, but we don't have time to go over many of them, so I'm going to focus just only on one of them, and this is something that we call derailment. So derailment happens in free speech, like what I'm speaking right now, and it happens when the speaker is jumping, between different topics, essentially moving away from the main topic. You can check out this example. It's a known old example. I always liked geography. My last teacher in that subject was Professor August A. He was a man with black eyes. I also like black eyes. There are also blue and gray eyes and other sorts too, right? So clearly you can see like a derailing effect moving from the main topic. And this is something that we want to detect using computational tools. So let me now introduce quickly a work that I've been working on recently with this list of people, great people here. And we're still working on it. We're still collecting data and producing results, but let me share with you some results that we published recently. And so in this work, we propose a computational approach for extracting some features from speech and its transcription. So it's not just NLP, we're also using tools for extracting features from the audio signal itself. And then we use these features to train a machine learning classifier to detect schizophrenia. So it's all about schizophrenia here. But I'm going to focus only on the derailment part because there are other thought disorders that we consider as part of this research, but I don't have time to go over them. But we didn't want to use the traditional Twitter or Reddit data. So we are collaborating with a mental health center here in Israel, Be'er Yaakov. And overall, we were able to collect speech samples from inpatients hospitalized, officially diagnosed with schizophrenia, and most of them in remission, medicated. And for a control group, people who don't suffer from schizophrenia, we simply collected speech samples from a demographically equivalent group of people. We put an ad on Facebook, and we collected these speech samples in two batches. So you can see like two groups with slightly different instructions between them, so they're not comparable. And our results for the first batch have already been published, and now we're working on the second batch. Every participant, we interviewed every participant, and in order to make them talk about the same thing, more or less, so we created a structured questionnaire with 18 different questions. In fact, 14 questions are just simple images that we show them, TAT images, if you're familiar with that. I'll show you an example in the next slide. And then 4 open questions. I mean, for the images, we just tell them to tell us to describe what they see in the picture. Of course, all this activity was approved by an IRB and Helsinki committee, and all ethics approvals were granted. Then all the interviews were manually transcribed twice to eliminate transcription errors, and then we processed the transcription with some tools that we developed. I will show you just one of them, very simple one quickly. And then I will also mention that all participants are native Hebrew speakers. We have other speakers as well, but here I'm going to show you everything is only Hebrew speakers. These are just examples for the TAT images. It's a known set of images. You can go online, put TAT images, you'll see some of them. So for derailment, we just, this is one set of features that we use, so just to give you a taste of what we have done. It's pretty simple. So we want to check if the speaker is jumping between different topics. What you see here, we calculate a score for every word in the text by comparing it to the K following word. So here, the second word in red, we take its embeddings and we calculate the cosine similarity of that word with 3, in this case, following words. And then we take the average of cosine similarities to represent word to score. And then we do this for all words, and we take their average, so we can represent the text with one score representing or reflecting the cohesiveness, right, of the text, more or less. We use fast text embeddings for Hebrew, but right now we're trying Aleph BERT as another option. Additionally, as I said, we extracted some features, but we don't have time to go into that related to the prosody, right? That's the shape of your voice, basically. I would say that prosody is a collective definition of intonation, tone, stress, rhythm. So we extracted some features. This is just a partial list. And in this work, the results I'm going to show you, so we took all these features and we fed a machine learning classifier, and we tried to see what it can produce. Despite the relatively small number of participants, of course. but we just we trained the machine learning, and then we evaluated that classifier with a tenfold cross-validation evaluation approach. Here are some results. We did this for the two groups separately because, as I said, I mean, we gave slightly different instructions to the interviewers, so they are not comparable. And by the way, the inpatients were taken from the same department in the hospital. So the first column that you see here, the results, this is all accuracy results. So because the data set is more or less balanced. And the first column is only when we use language features or language-related features, the same one I just showed you, but a little bit more than that. And the second column is when we use only prosody-related features. And the last column on the right is when we combine the two sets of features. So I won't have time to go into details, but I just want to put some numbers, and you can learn more about that in our papers if you want. Anyway, but it's nice to see how we got pretty good results in the second batch. And that was after we had to modify a little bit the instructions that we gave to the interviewers, so that the inpatients will speak more. So we needed more text from them in order to get to better levels of accuracy. So I want to conclude this session, and I would say that, I mean, there are many ways of using NLP to diagnose mental health disorders. Most of them are pretty simple, I have to say, but I think the main challenge remains, access to data, and this is why we're not using, sophisticated neural network approaches here for classification, because we don't have a lot of data. So we're trying to learn more about the features. That's what we're doing right now. But I have to say that in the last 2 years, maybe with COVID, hospitals and mental health centers in Israel and other places in the world are more open to share data, even in this field in mental health, in order to enable new directions of research in this field in mental health using AI. That's it. That's what I had for you today. Thank you so much for listening. I don't know if we have time for questions, but I'll be around.
Thank